Hello friends, welcome to our channel Lux Physics. So students, I am little bit more. Hi, hi there, hi. Hello everyone. Good evening to all of you. Now students, it's now exam time and we are never to be low at any point. So that is very important to stay hydrated and be calm as well as complete your whole syllabus within a stipulated time. So for reducing that time, today we are going to discuss important questions that are only asked in the examination. Okay, so we will discuss on the unit number 3, that is the conductivity of conductor, semiconductor and superconductor. So now we will directly go through the directly questions. So the first question asked many times, that is the electrical conductivity of conductor. So in this case the question are like 2 marks, 2-mark question and 10-mark question is there. Okay, so 10-mark question is like whole the derivation you have to write, or the 2-mark question is like equation of electrical conductivity of conductor. So that means only 2 questions from this topic they will be asking. So first question is equation of electrical conductivity. So what is the end result? That is this: conductivity is directly proportional to the Ne mu E. This is your equation and that is you have to write it well. So mu E, E is now here is the suffix and this E is not the suffix, it is the normal. So this is the case. This is for 2 marks and definitely the question is asked many times and this time is also probably asking. So this question is there, and again most important 10-mark question, electrical conductivity of conductor. So in this case we have to like consider a one conductor having a length of L, area, having voltage power supply, then this one is the electrons moving inside the conductor. So suppose N is the number of electrons per unit volume. If we have a specified area of length of conductor, then it has a some number of, मतलब यहाँ पे कोई भी अगर एरिया है आपके पास कंडक्टर का, तो उसमें आपको नंबर ऑफ एटम, नंबर ऑफ इलेक्ट्रॉन्स प्रेजेंट रहेंगे. तो इन दैट केस, हाउ मेनी नंबर ऑफ electrons be present inside that conductor, that will be find out that by using the formula number of electrons present in the conductor is equal to n multiplied by volume. So in this case the volume will be simple, length into area. This one is your area, right? So n is the number of electrons present per unit volume, that is the NaL. So this one is for finding the number of electrons in the conductor. Then charge on one electron is E. Charge on one electron is E. Now the total charge on the conductor is like whatever the area. Total Q is nothing but the charge on one electron multiplied by a number of electrons in the conductor. Okay, so this one is that much Simple. So Q is nothing but whatever the first you finding, only put it with the n value. That is simple. Then you know that whenever the electrons are moving from one location to another location, then the current will be flowing through that, right? So I is nothing but the Q by T. I is what? Electrons moving per unit time. That is nothing but the current. But we are already finding Q here, right now? So just put it Q value. Okay. Then after that, whatever L by T, here is something you can see. So L by T is nothing but the velocity, and we will call it as a drift velocity, as that of simple. As you know that L by T, you can see, as you know that distance divided by time is nothing but our velocity, and we will just put it a small d, that is the drift velocity. No many conflicts, put it in your mind. Be calm and just go through one by one steps. First find number of electrons in the conductor, then charge on the conductor, and then current. Just इतना ही करना है बस. Then put L by T as Vd. Then just one equation you have to put it extra, that is Vd is equal to mu E. That is nothing but the electrostatic equation of drift velocity. ये आपको याद रखना पड़ेगा. Vd is equal to mu E. That is important. And then our equation is like this. I is equal to Ne A mu E. This suffix is very much important. So please put it in mind. The suffix and the normal E. A lot of students are confused in that, and that's why they are lose their marks. So that is very much important. If you people understand, then please put them in the comment box, so that I will confirm the situations, or if you have any query, like if any steps you cannot understand, then put it in the comment box so I can explain it more. Then you are finding I value, then apply directly Ohm's law. V is equal to I R. Then what is the value of R? V by I. Simple. But the resistance, whatever you know, that is nothing but rho L by A. This formula we are studying many times. Many times means like in the 10th, 12th, or in the 7th, 8th class also, we are studying that formula. Resistance is directly proportional to the length per unit area, and as well as we are putting a rho, that is the resistivity. Okay, so this one is here. Then we are putting the values here. So R is this. R is equal to rho L by A. Then whatever your V is equal to IR, then equation number 4, equation number 5. We can convert that V equal to IR by I is equal to V upon R. Okay. So in this case, whatever the value of R, you can put it here. V divided by rho L and divided by A. So we can again divide by divide, that means multiply. Okay. This. So this equation is coming here. Got it? So whenever we are finding the value of I here, this I value at equation number 3. Sorry. Equation number 3, that is came from the initial ones. That one. Okay. So this equation and this equation both are of a current equations. So what we are doing? We are just equating both the same values. So one I value I am writing here, and another I value I am writing it here. Okay. So again, here you know that V by L is nothing but our E energy. Sorry, E is equal to V by L. So in the equation, we have to put V by L is equal to E. So in the equation number 7, you can see here V by L. So that V by L now be replaced by E value. Okay, so EA upon rho and the remaining terms are same. Now you just see the equation, left side and right side. So you can visibly see that some points or some numbers are same, EA, EA. So whatever the both the sides we are just cancelling out. Okay, then whatever the remaining terms, 1 by rho, here is 1 remaining, then another 2 will be remain. So whatever the remaining term will be writing it here. Okay, 1 by rho is equal to Ne mu E. Now you people know that whenever the rho conductivity and resistivity, both the values are reciprocal of each other. So that means 1 by rho is the conduct resistivity. So 1 by rho is nothing but now our conductivity, and we will replace or signified conductivity by the equation of sigma. So this is the last point. Sigma is equal to Ne mu E. If anyone is not understanding the steps, so I am providing this PPT in the comment box or in the description link so that you can understand this later on also. Okay. Thank you so much for watching. Now, question number 2. Like I already consider it here 2 questions. One is 2 marks and one is 10 marks. So 2 mark question is write the equation of the conductivity of conductor, and the second equation is what? Total whole 10 mark question is whole equation. You have to write. That is the thing. Good evening, Rupesh. Thank you for coming. Now, the next point is conductivity of semiconductor. Again, the same thing is there. Whenever we are deriving the equation for conductor, same to same equation, you have to put it in the semiconductor also. But the only small change is there, because in the conductor, only electrons are present in the conductor, while in the semiconductor, what is happen? Electrons plus holes. Both the things are present in the semiconductors. Okay. So that is why the equation will be changed. So how it will be changed? As we already done the how we are finding the currents in the equations. By whenever we are having any conductor, then in that case, how we are finding the value of I. ठीक है, तो उसमें क्या करेंगे फिर? Whatever the derivations we are using in the conductor, same equation you are putting, but the total current is what? IE plus IH. That means the current flowing because of holes as well as current flowing because of electrons. Simple. Then whatever your last equation coming, where here this is your last equation for electrons, right now. So the same equation you have to put it here for electron, and little bit changes like VE is equal to mu E, and then put it again in the VE value or drift velocity value. That is the case. Okay. Then after that, the same equation of this and this you have to write it for holes. Just replace IE by replace small e or suffix e by h. Only this thing you have to keep in your mind. Okay, what you have to remember, whatever the equation come for IE, that is same for IH. But the only thing is that you have to change the suffix. Okay, then already we are know that I is equal to already we know that I is equal to IE I is equal to IE plus IH. So we just add both the things. So here you see that whenever we are adding both the terms, then EA, EA and capital E, that are common terms. So we are, what we are doing, we are taken as a common, and whatever the remaining term NE, mu E, NH, mu H, we are writing it in the bracket. Only do these things, and after that again same thing, we are finding the current, right now. So after finding the current, what you have to do, you have to do again apply Ohm's law. Then you know that R is equal to rho L by A. Again I finding I, then again this is I and this I. Equation number 6 and equation number 7, you have to equate again. Then whenever equating, you see that V by L is again E. Again put it at E. Okay. Then whatever the remaining term, EA upon rho is equal to EAE NE mu E plus NH mu H. Okay. Please keep in mind that small h and capital H. Guys, please put a message in the, put comment in the comment box. Then E is common, AA is common, and the remaining terms you have to write it as it is. Again we know that 1 by sigma, 1 by rho is equal to sigma. Then we are writing it like this: sigma E NE mu E plus NH mu H. Now the best part of the equation is whenever they are asking a question for 5 marks, that is already you face the problem regarding this question, like state the equation or derive the equation for P type, right now, P type and N type semiconductor, right? This question asked and you people don't know about it. So in this case what you have to do, you know this equation, right? You know this equation, or either you derive this equation for 10 marks, you derive this equation, at the end whatever the, I am just writing the equation again, NE mu E plus NH mu H. Okay, so in this case if they are asking for P type, so P type means holes are the majority carriers, right now. So holes are the majority carriers, and in that case what you have to do, like electrons are negligible or you can neglect it, right? So sigma is equal to E NH mu H. Suffix should be important. Okay, right? So this is the equation for P type. If they are asking only for 2 marks, then you are directly go through this only. And if they are asking for 5 or 10 marks, then go through the whole equation. Equation is very much simple. You just have to remember only the one line, that is I is equal to, that is I is equal to NEA mu E E. You just have to remember this thing, and you have to just add it for the two currents, holes, current due to holes and current due to electron. Just these things you have to remember. This is for P type, and for N type it is like whenever N type is there, that means the electrons are the majority carriers. In this case holes are negligible, so sigma value is directly NE mu E. So this is the case here. Okay, so you people please keep in mind that these things are very crucial and important because of their importance, like for 5 marks, for 10 marks. Any question they ask for semiconductor as well as P type or N type. So P type or N type, that means the extrinsic semiconductor, and total equation if they are asking, they are writing it there only for semiconductor, or intrinsic Don't confused with the words. Intrinsic semiconductor and extrinsic semiconductor, right? Then students go for the very important question, that is depending on the Hall effect. So in the Hall effect, when the current carrying, like here again a 2 mark question, right? Hall effect, or what is the define concept, define Hall effect, or for 5 marks or 10 marks they are asking derive equation for Hall voltage, Hall voltage. So this is the case where they are asking the question. So simple is that when the current carrying strip, this is the current carrying strip, is kept in the magnetic field, transverse magnetic field. So in that case, the potential difference is developed which is perpendicular to the direction of magnetic field and current. So that means whenever the metal strip is kept like this, okay, and whenever the current is flowing in this direction and magnetic field is in this direction, then the potential difference is developed in this direction. That means the perpendicular directions with the current and the magnetic field. That is the case, and whatever the voltage is developed across that two ways, that is nothing but the Hall voltage. Again, here you see that electric field and magnetic field, both the fields are present here. So whatever the force is exerted on the electron or hole for creating the potential difference, that is because of a magnetic force, Fb is equal to E V cross B, or either we can cross convert it into the sine theta. And again the one thing is there, if the angle between V and B is 90 degree, so sine 90 is 1. So the force due to the magnetic field is now Fb is equal to EV capital B. Okay. Then the force due to the electric field, that is Fe is equal to small e h. Whatever the terms are there, only you can consider electric field is there and magnetic field is there, right? So the magnetic field force is EVB and electric field force is EE, right? Both the forces are equal at the equilibrium conditions. So we are writing it here, Fe is equal to Fb. So we are just writing the equations, then EE will be cancelling at here, and then EH is equal to VB. But as we are studying in the last equation also, E is nothing but V by D or V by L. D is here taken as a distance between the strip or the width between the strip, but we can consider it as a L also. But here I am denoting it as a D, that's why we are taken it here as a D. Okay, so EH is equal to VH by D. So again putting in the equation number 3, so VH by D is equal to VB. Okay, so again this D is now multiplied it here, so this is our VH, and we will call it as a Hall voltage. अगर हॉल वोल्टेज पूछा तो इतने तक ही लिखना है. अगर हॉल कोएफिशिएंट बोला, if they are asking for Hall coefficient, then little bit more, I is equal to NeVA. Okay, this one is the current equation. We are deriving it in the last derivation. You just have to remember it. Then small v is equal to 1 upon whatever the remaining terms, I upon NeA. Okay, only just do the things. Then whatever the remaining term, VH is equal to BVD. Now V is what? I upon NEA. So put it here. VH is equal to BDV, and V is what? I upon NEA. So we are just putting it here. Now we are just replacing or rearranging the terms little bit. So in that case, 1 upon NE, this term is now our RH. So RH is what? Hall coefficient, and that is enough for the equation, or we are writing it here as VH is equal to RH PID by A, and this is your last equation for Hall voltage. 2 marks question and 10 mark question, both the questions will be now here. If you want to add one more question, that is what is the applications or what we know when we having the Hall voltage value, like we know from this which type of semiconductor is there, or we are just confirming type of semiconductor from this equation, or we are finding the Hall voltage charge carrier from this equation, or these are the applications of Hall voltage. Students, don't get panic, just revise the things, write it on a paper, see it, and then just clarify the points. Don't get it confused too much. Then already I am writing the applications here. Now we will go for the very, like, our topic is divided or unit is divided into two parts. One is the conductor semiconductor and another one is the superconductor. So I will just take a brief of small 2-3 questions that are mostly asked in the examinations, and then we will stop here. So the superconductor, in that superconductor, isotope effect asks for 5 marks, as they are asking for 2 marks also, for 5 marks also. Okay, if they are asking for 2 marks, then it will be like the critical temperature is found to be inversely proportional to the square root of isotopic mass. That is enough. That is for 2 marks. If they are asking for the 5 marks, then go through the whole thing. Like, you people know about the isotope. So isotope, that means same atomic mass, same atomic number, and different atomic mass number. Good evening. Different atomic mass number. Okay, so as we know that we have an isotope, so for different isotopes the critical temperatures of the isotopes are different. Okay, so Tc is the critical temperature which is directly proportional to the 1 upon square root of m, and that is the case. That is enough. Now you people want to extend the little bit equation, then you can just extend it up to this and then go through the 1-2 lines extra more for the 5 mark question. Okay, that is enough for the isotope. Then Meissner effect, as we already know that what is the Meissner effect. Meissner effect is nothing but whenever the temperature is greater than its the critical temperature is greater than its the critical temperature, then in that case whenever we are applying the magnetic field, then the magnetic field lines are going inside that material, and if whenever the temperature will be less than its critical temperature, less than or equal to its critical temperature, then in that case the magnetic field, you can see here, magnetic field will be expelled by the material, and that is nothing but the superconducting state, and that is the, like, that superconductor will be now act as a diamagnetic material, that is expelling the magnetic field. That is nothing but the Meissner effect. So you have to write it whole thing of definition, write this figure and this one, this equation B is equal to mu H plus M. Here the magnetic field at the superconducting state, the magnetic field is not going inside that material. That means the magnetic field inside the material is 0, so you can consider it as a B equal to 0. Mu is, whenever it is coming here, 0 into mu 0, that is the 0, that M is equal to minus of H, or M by H is nothing but the minus 1. Whenever M by H is nothing but the susceptibility, and susceptibility is minus 1, that case is nothing but the diamagnetic case. So whenever the superconducting material is behave as a diamagnetic material, then we will call it as a Meissner effect. So you just have to go through, this is for 5-mark question, definition, this figure and these 3 things. That is enough for the 5 marks. Okay, and then last, that is for 10 marks, no doubt, because on this superconductor not much more questions are there. So that's why we can only go through this important question for 5 marks. So what is the type 1 and type 2 superconductor, right? As we are studying the critical temperature and whole thing, so critical temperature, in this case, whenever the type 1 superconductor is there, that means the कंडक्टर एग्जिबिट अ कंप्लीट मेजनर इफेक्ट, मीन्स अगर आपके पास टाइप 1 सुपर कंडक्टर है तो वो मेजनर इफेक्ट को एग्जिबिट करेगा, मतलब जब भी उसके ऊपर से मैग्नेटिक फील्ड जाएगी सुपर कंडक्टिंग स्टेट में तो वो एक्सपेल हो जाएगी. बट वेन एवर वी हैव अ सुपर कंडक्टर टाइप 2, देन इट डज नॉट एग्जिबिट अ मेजनर इफेक्ट कंप्लीटली. ओके, सिंपल. फर्स्ट पॉइंट क्या है आपका, मेजनर इफेक्ट का. अगर मेजनर इफेक्ट मतलब अगर मेजनर इफेक्ट एग्जिबिट कर रहा है, दैट मीन्स इट इज द परफेक्ट डायमैग्नेटिक. सिंपल. इसी के ऊपर आपका दूसरा पॉइंट भी आ जाता है, राइट ना. ये फर्स्ट है और ये सेकंड पॉइंट है. अगर परफेक्टली एग्जिबिट नहीं कर रहा है मेजनर इफेक्ट, दैट मीन्स इट इज नॉट शोइंग अ परफेक्टली डायमैग्नेटिक बिहेवियर. ये सिर्फ आपको क्या करना है, इसको रीराइट करते चलना है. और एक और चीज, आपको ये फिगर्स जो है, इस एक फिगर को और ये दूसरा फिगर, इन दोनों को याद रखना है और उसी के हिसाब से 2-3 चीजें और लिख देनी. अभी एक तो 2 पॉइंट मेजनर इफेक्ट पे आ गए, तीसरा चौथा जितने भी पॉइंट्स है वो सिर्फ इस फिगर पे आएंगे. यहाँ पे देखो, इस फिगर में आपको दिखाई देगा कि यहां से जब मैग्नेटिक फील्ड, अप्लाइड मैग्नेटिक फील्ड इंक्रीज हो रही है तो उसी टाइम पे आपका इंड्यूस्ड मैग्नेटिक फील्ड भी इंक्रीज हो रहा है. बट at the when it is in the superconducting state, at which Hc is less than value, Hc value less than Hc value. After increasing the applied magnetic field, it will be now converted into the normal conductor. Here you see that only one Hc value is here. That means only one Hc value is required for the superconductor to convert from superconducting state to the normal state. Okay, so that is Hc, and here you see there is one Hc1, Hc2. That means 2 magnetic flux will be required here. So 2 critical magnetic fields are there. One is low, Hc1 is called as a low critical magnetic field, and Hc2 is called as a upper critical magnetic field. Okay, so here you see that this is your superconducting state, here this is your mixed state, and after the Hc2, whole superconductor is now converted into the normal superconductor. And mixed state is what, some kind of, it is the material is behaving like a superconductor also and a normal conductor also. ठीक है, इतना लिखना है. उसके बाद वेरिएशन ऑफ मैग्नेटाइजेशन ऑफ सुपरकंडक्टर विद द अप्लाइड मैग्नेटिक फील्ड, ये तो दोनों में ही आएगा. वेरिएशन मैग्नेटाइजेशन जो इंड्यूस्ड मैग्नेटिक फील्ड है, दैट विल बी चेंज्ड अकॉर्डिंग टू द अप्लाइड मैग्नेटिक फील्ड, दैट इज द सेम थिंग. एंड वट एवर द स्टेट यू सी और Hc वैल्यूज यू सीन इन द figure, that is you just have to write in the 5th point. In this in this question, 1.1 mark. So that means if you have to distinguish it, then 1 point here, 1 point here, 2 marks, 2 point here, 2 point here. That means in the left side 5 point, right side 5 point. That is enough to give you a 10 marks. But you have to draw this figure. That is very much important. If you are drawing this figure, then in that case you got the 100% marks. But please keep in mind that whenever you are drawing the figure, which sentence you have to, or which point you have to write it there, that is very much important. Okay, अगर किसी को ज्यादा लिखना है तो आप ये लिख सकते हो, मटेरियल लॉसेस मैग्नेटाइजेशन अब्रुप्टली, मटेरियल लूजेस मैग्नेटाइजेशन ग्रेजुअली. दैट मीन्स जो फिगर में देखा था आपने, डायरेक्टली सडनली in this figure you see that it is directly coming to 0, but here it is not like that. It is gradually becoming a 0 value. So that is the another point. And then whatever the type 1, we will call it as a soft superconductor, and type 2 we will call it as a hard superconductor. ये तो मतलब ये point अगर आप लिख दोगे तो 100% you got a 2 marks. That is enough. And now last one is the application of superconductor. So here in this case you just take a screenshot of that and you just remember it. Okay, thank you so much students to join a live session, as well as you see this video at later. I am providing this whole PPT in the description box. You people please take it and please study well. All the best for your examination. And again 2 videos we are taken for the video number 4, unit number 4, unit number 5, that is nanomaterials, and unit number 4 is the optics. So we are taken the important points here and we will stop now. Thank you so much.